So Scott, which trig function would you use for number 15?
Opposite my hypotenuse from sine.
Very good. So tell me the equation, please.
Is the sine 50 degrees equals 100 over x.
Good. And how would you solve that?
But, secant equals x over 100.
Well, I'm just writing that as, because some people like to do that. This James kind of inspired me to do that.
And if you multiply 1.
But it's however way you want to do it.
I'll do that one.
Okay.
You can multiply 100 by cosecant of 50 degrees.
Okay. So you're using this one. Yep.
Yep. 130.54.
So how are you getting 130.54?
It's 100 times 1 divided by sine 50.
I'm with you. 100 times 1 divided by sine 50. Good. Okay. Any questions on 15? Okay, now we're on the back. Liam. Hi. Notice what's different about the problems on the back. What would you say is different? Here you're given sides and you're finding angles. Yeah, on the previous side you're given the angle and you want to find a side. Good. So can you tell me what trig function you could use for this one? Sine, because you have opposite and hypotenuse. So you have sine of L equals what? 8 over 15. Now how would you solve for L without using a protractor or a table of sine values? How could you use your calculator? Okay, so you're going to use inverse sine, which is second sine of 8 over 15. When you want to find angles in trig, you use an inverse trig function. That undoes the trig ratio and tells you the angle for which that trig ratio is that value. So it's 32. They want us round it to the nearest degree, so about 32 degrees. Okay, very helpful. No protractor needed. The calculator tells you the value. Any questions on that one? Good. Next random helper is Natalie. How could you solve the next one?
Sine m
Sine m
equals 4.7 over 6.4.
equals 4.7 over 6.4. Okay, so inverse sine of 4.7 over 6.4. Good. 47 degrees. Good. Darian, next one. What would you do?
I did tangent. I did 34 over 80.
Yep, tan of D equals 34 over 80. Very good.
And I'm pretty sure I got 23.
And how did you get that?
I did the inverse of tan.
Very good. Inverse tan of 34 divided by 80, 23 degrees. Just stop me if you have a question. So notice you're using inverse trig functions for all of these when you're solving for the angles and you're given the sides. Sam, could you help me with the next one?
So here's cosine of A
Great idea.
equals 6
Good. And then?
And then you have to use the inverse of cosine.
Nice. Good.
And that gives you 40.
Nice. Well done. And Jackie, help me solve the next one, please.
You do sine of t
And why?
because 27 is at a hypotenuse, and that's the opposite.
Good.
So you do 27, you do 25 over 27,
Mhm.
but inverse of sine.
Good. Inverse sine of 25 over 27. 68 degrees. And James, help me out, please, with the next one.
What is that?
B.
B, okay, so I would do the cosine of, inverse cosine of 38 over 50.
Inverse cosine of 38 over 50. Nice job.
And I got 53.
Sometimes I speak too soon, though.
Oh,
So is 50 the hypotenuse?
no,
It is not.
I meant to say inverse tangent.
Inverse tangent, I think, is a better option here.
And in that case, it would be 50 over 38.
It would be 50 over 38, yes. Okay, so choose the trig function appropriately. Inverse tangent of opposite over adjacent. The angle is 53 degrees, for which that's the case. Okay. Darian, next one. Just tell me what inverse trig function it is and what to plug in.
Inverse of cosine.
Inverse cosine of
You do 4.3 divided by 5.
4.3 divided by 5.8. Okay? I'm going to move a little bit faster now. Ashley, next one. Just tell me the inverse trig function and the numbers to put after it. Very good. Inverse cosine of 707 divided by 1,000. Thank you. Adjacent over hypotenuse. Liam, W. Inverse tan of 9 over 18. Very good. And Natalie, letter K. Just tell me the inverse trig function and what you put after it. Inverse cosine of 40 over 116. Good. Okay? Any questions on the non-word problems part? Good. Sounds like you've got the hang of it. Now let's put these things to work. Working on my trig. An access ramp rises 3.2 feet over a distance of 30 feet. What is the angle of the ramp with the horizontal? When they draw the diagrams for you, it's quite easy. Soon you'll have practice with drawing the diagrams from the wording. A random person is Noi. Hi. Can you tell me which trig function to use or which inverse trig function to use? Cosine? Mm-hmm. So inverse cosine of what? Did you say 16? Oh, this one I'm referring to. Do you want to use cosine? Let's use tangent. And then tell me what numbers to put in. Good. Okay. Anthony. Hi. Still alive. We need to figure out the angle of descent here. It's angle S. We've got a plane that has descended 1,000 feet. And planes can do that easily. They use gauges called altimeters to do that. And it knows that it has flown 2.7 miles. We want to know what has the angle of descent been. Right triangles are your friends. They are used to solve many problems. So Anthony, any idea how to set this up?
I think so we're going to need to do tangent.
Very good.
So
Because we have opposite
yeah.
and is this adjacent?
Yeah. So we're going to
It's not. So like I was telling James, sometimes I speak too soon. It's because I'm positive, you know. I want to say good job, but sometimes it's just inaccurate. So we'll try again.
So it's not tangent.
I would not use tangent here because tangent's opposite over adjacent. And this is not what's called the adjacent side because it is opposite of the right angle.
So it's sine.
Let's try sine.
Yeah. I was looking at it from the right angle side. I wasn't looking at the right angle.
It happens to us all. So
Okay.
sine of what?
So there'll be 100 over 2.7. I mean,
Sine of what? So when I say of what, you're going to give me an angle. S, good. Equals
1,000 over 2.7.
1,000 over 2.7. And then what would you do?
Solve it.
How?
1,000 over 2.7.
Okay. And then what would you do? No. So apparently what you found is the ratio of two sides of a triangle.
Okay.
We are looking for an angle in a right triangle.
Okay.
Without using a protractor, how do you think you can find that angle?
Isn't it 30, 60, 90 or something?
It is not. So what you'll notice with all of these problems here, we're using an inverse trig function.
Okay.
Like inverse sine, inverse cosine, inverse tangent. Anytime you want to find an angle in a right triangle, I recommend using an inverse trig function.
Okay. So we gotta find the inverse for sine?
Inverse sine, and notice what happens. You get an error. Do you know why that is?
It's not possible.
It's not possible for the sine ratio to be something like 370.
Okay.
Yeah. The problem here is that this is in miles. This is in feet. So we either have to convert this to miles or this to feet. Because it's impossible for the hypotenuse to be less than the opposite side. That's why it's giving us an error. Okay? So what do you want to do? Convert this to miles or this to feet?
Doesn't matter.
Okay. Let's do this to feet.
Okay.
So what do you have to do to the 2.7 to make it into feet instead of miles?
Divide it by 5,280. Or multiply.
Now here's the deal with dividing. When you divide a number, it makes it smaller.
Multiply.
You want to make it bigger because there's a lot of feet in a mile, so you're going to want to multiply. That's what helps me to know which one I should choose. Another option you have is to use kind of a dimensional analysis type approach, which has saved my butt on many occasions when I don't really know what's going on, but I know what units the final answer has to be in. Because you don't want miles here, you need to put miles in the denominator. And then it will cancel. And then you put the conversion up top. So there's 5280 feet in 1 mile. Now the feets will cancel. Okay, so inverse sine of 1,000 divided by the product of 2.7 and 5,280. Okay, so about 4 degrees. So notice that the units have to be the same. Good. Okay, Alec. It's about 4 degrees. Alec, set me up here for this one, please. Good. Yeah, inverse cosine of. Very good. And then Jake. I'm trying to figure out how high we have to tilt the camera up to take a photograph of a rocket here at point X. Apparently the rocket's gone up 3 kilometers and we're 5 kilometers away from its launch site. Inverse tangent of 3 over 5. Good. Any questions on that side? Okay, consider the number 6. Consider numbers that can round to the number 6. So give me a number that could round to 6.
5.98.
5.98. Give me another number. 5.5. How about a number bigger than 6?
6.04.
6.04. Great. What they're challenging you to do here is to think about the range of values that could lead to a rounded answer of 6. Like the widest range of values. Letter A? I agree. 5.5 could round to 6. Now, in period 5, we had a debate or discussion. Some people had an issue with the fact that 6.5 was in the answer here.
Yeah, it should be 6.4.
Because they said that should round to 7. And I'm in agreement there. So if I were to rewrite this, I would write this to something like 6.49. Okay? What's most important to me, though, is that you understand the concept that these numbers are going to be rounding to something like 6. Okay, next. Sam, what do you think could round to 6.5 among these answer choices? What's the widest range of values that you think would round to 6.5? Maybe A. So this is definitely going to round to 6.5, as does this. So that's an option, but it's not the widest range of values. Let's take a look at C. C has, I think, a better choice. However, I would revise this one to 6.4. 6.549 because it just has to be a hair under 6.55.
Okay, my final answer is D.
Your final answer is D. These values here will indeed round to 6.5, but they don't include the entire range. So something like 6.48 would round to 6.5, but it's not in this range. They, I think, want the widest range possible that would round to 6.5. So I would choose letter C.
I didn't know because it said 6.55.
I know.
Round up.
I have an issue with it as well. So when I revise this worksheet, I'll change it to something like that for the second one. 6.549. Yeah. Okay. Good. Jake, what do you think is the widest range that would round to 9.69?
If you change the C, the last one, to 9.694, then I think that would.
Yeah, I agree with you. Okay? Nice job, Jake. Any?
I didn't know though.
Know what?
Like, all of them are so similar. I don't think
Here's a quick way to do it. Take the last digit and go plus or minus half from that, like with the next decimal coming into play. So, like, if you go half of, it would be 1,000th? No, half of 100th, because this is the hundredths place. So if you go half of 100th down and half of 100th up, those both will round to 9.69. So, like, 9.69 minus 0.005, and then 9.69 plus 0.005. So you take the next digit, or the next decimal place, and you go plus or minus half of that, or half of the previous one, I should say. It's kind of a tough thing to explain. Ultimately, what you want are numbers that round to 9.69. Okay? Good. Okay, Jackie, can you tell me how to find sine of angle A for number 4?
So since sine is opposite of the hypotenuse,
Good.
you have to find the missing side.
Excellent.
So if you do 9 squared plus 2 squared equals x squared, and then you get root 85. Which rounds to 9.22.
Okay.
And then you do 9 divided by 9.22, but you do second sine 9 divided by.
I don't think you want second sine, because that would be if you were looking for an angle.
Well, sine A is an angle.
That is true. So you do need that to solve this correctly, but you're not going to use second sine, because that's if you want to find an angle. They're just asking you for the sine, which is a ratio of sides.
So it's going to be 9. Point 9 is going to be 6.
Very good.
So when would you have to use second? If it said
If
find
they
A,
ask for an angle,
but they're asking to find A.
they are not. They're asking for the sine of A, which is our kind of fancy terminology for opposite over hypotenuse, with A as the reference. Trig functions are just ratios. Good. Next up, Alec, could you help me find side B?
Sure. Opposite over
Side of A would be what, 9 over
Here's the issue. You don't have opposite or adjacent.
Yeah,
I think you do. You're a bright boy. So what do you have? Which trig function do you have?
Which one are we on 5 or 6?
We are on 5.
cosine.
I like cosine because you're looking for side B and you're given the hypotenuse. So set me up, please.
Alright. B over 21.
B over 621 equals. It's a good start.
Cosine of 36 degrees.
Cosine of 36 degrees.
And 30.
Good. And how would you solve that?
Multiplied by 621.
Nice. 621 cosine of 36 degrees 30 minutes. So side B is 499.20. Nice. Jordan, could you set up the equation for number 6, please? Trig, so katoa. So pick a trig function that's based on the side that you know and what you're trying to find. So you're trying to find B and you know this side.
So sine.
So the deal with
Cosine.
we are not looking for the hypotenuse, so I wouldn't choose sine or cosine.
Tangent.
What do you think?
Tangent.
Tangent. Okay, so tell me, tangent of
B.
tangent of
C.
well, I would use the angle that's given.
Okay.
So 32 degrees, 40 minutes, and then tell me what does that equal?
63.5 over X.
Yep. Okay, and then how would you solve an equation like that?
I have no idea.
So here's one option. You can cross multiply. So you would get B tan 3240 equals 63.5. And then you can divide both sides by the tangent part. And just use your calculator.
Easier to find the tangent part first.
You certainly can. I like to be really precise. You'll have to forgive that personality trait of mine. So it looks like 99. Okay. Good. Jackie, number 7. What trig function should I use if I want to find B?
You want to find B?
I do.
We're going to do
Okay.
Equals sine of 65.4834.
Good. And you can thank your helpers over there. Okay, so then you just multiply 3193.8 times sine of 65.4834. So it looks like side B is 2,905.85 meters. Good.